So hi everyone, my name is Nikhil Barthwal. I work at jet.com. I use FSharp every day, right? This is more of an introductory talk to FSharp. The scope is that basically I provide some aspects of what functional programming is, what is specific about FSharp. So it kind of gives you a little bit of context on when you should be using FSharp. Obviously, like any language, I don't intend to bore you with all the mundane details. So I'm just going to cover some high-level stuff, and then I have pointers at the end. So if you're interested, you can go to the specific links and explore more. Just to keep it interactive, if you guys have any questions anytime, just feel free to interrupt me. Right? Okay. So these are the objectives. So it covers what is functional programming, why do you want to use functional programming, specifically about FSharp, and some sample FSharp code that we're going to look at. Excellent. So functional programming is basically a programming paradigm. This is the boring high school talk. You have the object-oriented programming, you have the imperative programming. Everybody knows C++. The unique feature about functional programming is that functions are the building blocks. So let me contrast it with object-oriented programming, where you have the concept of a class, right? An object as an instance of class, and you have the state, which is represented by the attributes of the class, and you manipulate that state through its public functions. In a pure functional language, and I'm going to explore what pure functional language is later on. In a pure functional language, the basic building blocks are functions, and you can combine these functions into what is called as a higher order function. So you can take two functions and combine them as a third function, and we'll see example of how it is the data is immutable. That is to say that once I declare a variable, let's say let x equal to 3, that's it. You cannot change the value. So it's something similar to C++ const, right? Or in CSharp you have the read-only, right? Once you instantiate it, you cannot change it. FSharp, FYI, is not a pure functional language, so it does allow you to change that, and I'm going to cover up. Yeah, please. Yeah. So I'm going to cover up some examples of when you can and when you cannot change. It's more of a declarative style of programming, so I'm going to have a code sample here and show you what I actually mean by declarative function. But the unique feature of a pure functional language is that it does not have side effects. So if you have a function that takes an input, let's say x and y, and gives you an output, your output will only depend on x and y. So as many times as you call that function with the same values, you will get the same answer. There will be the values would not be different. Now in C++, because you have the state that is not visible to you, right? Let's say I have a class that has an internal variable that increments each time you call, and then every time I call a variable adds it to it. Each time you call a function of that class, you actually would have a different value because the internal state is being manipulated. In functional programming, you don't have that concept of state. So that is why it has what is called as a no side effects. FSharp again is not a pure functional language, so you do have side effects, and in practical programming you need side effects because you want to do I/O with the devices, right? So I/O by definition is a side effect, right? Because you have an environment on which your program is running, you're interacting with the user, you're outputting something, you are actually interacting with the environment and manipulating the state of the environment. So that's why most functional languages, with the exception of Haskell, actually do allow you to have some side effects. FSharp is no exception to it. When we get to code, again, it will become more clear. So what are the advantages of functional programming? In general, the code that you have in functional programming tend to be a lot shorter, a lot concise, I would say by an order of 2 to 3 times. And the reason why you have is because you have these functions and you're building higher order functions from smaller functions, you're actually reusing a lot of code that's already been defined. So it follows the principle of don't repeat yourself. Again, it may not make a lot of sense now, but when you see the code, it kind of becomes more clear. Because you don't have a state involved, you actually have a lot less bugs on a corresponding functional program. And the reason why bugs exist is there was a once I attended a talk by the C# guys, and they said that what are the three main reasons why your program has bugs? And the three main reasons were memory, memory, memory. Okay. What is a memory? Memory is a state, right? It's a state where you're manipulating the value. And the common thing is it gets corrupted for whatever reason. So you have a program that writes some data in memory location X, then you do something else, meanwhile another program manipulates the same manipulation, and then you were expecting something and it happens something else, and there you go, you have a surprise. Because functional programming does not have the state involved, right? Usually you would avoid that whole class of bugs outside. So that's the reason why functional programs tend to be a lot less buggy. Now, that said, there are cases where you need state. For example, if you want to define a user interface, you actually do want to have a state. So FSharp in particular does allow you to have all the constructs because it's a multi-paradigm programming language. Again, I'm going to cover up, it actually supports object-oriented, so where you do need a state, it does give you the option of defining a state. But anyway, functional programming in general doesn't allow you to have a state. Because it's more declarative, the code is a lot easier to understand. You predict the behavior because you don't have the hidden state. All this might sound like an abstract theory, but again, when we come to the code, it becomes a lot more clear. And last, but a very important point, is it's very easy to parallelize the code. And the reason why you can do that comes back to this case, because you don't have state. Each function depends on its input only, right? I could have 10 instances of that function running simultaneously. I don't have to worry about them interfering with each other because there is no side effect. One cannot affect another. So functional programs by definition lends themselves to parallel programming very well. It's actually particularly in Haskell, you could have literally thousands and thousands of threads running simultaneously without any issues. So again, by functional programming, it's a code that I took from the internet. The goal of the functional programming basically is to make things easy that were hard to code. Lets you write programs that are concise, bug-free, and parallelizable. So having talked about functional programming, let's talk about FSharp. So what is FSharp? FSharp is a mature, open source, cross-platform, functional first programming language. Now, it says functional first. The reason why it says functional first is it's predominantly geared towards functional programming, but it does support imperative and object-oriented programming. Very complex computational problems, particularly mathematical, when you're solving maths-oriented problems, actually they become very easy to solve in FSharp. And this is a bit of a history of FSharp. So FSharp essentially shares a very similar code to the language called OCaml, which stands it's Object Categorical Abstract Machine Language for those who are interested in what OCaml stands for, but it actually was a language developed in India, France in 1996. 1996, I think, was Camel, and then they added the O in 98, which is object-oriented Camel. And FSharp is built on .NET platforms. It supports a lot of C# and .NET construction. This actually is a major plus point because it's built on .NET. If you have a huge code base of C#, you actually can have FSharp code interact with it. So FSharp can use C# classes, C# can use FSharp. They're all based on .NET. They can be connected seamlessly. And this is one of the reasons why FSharp is actually very much used. For example, because .NET is a standard platform. See, when I'm programming with something like OCaml or Haskell, a big concern for me is third-party library support, right? Because FSharp is based on .NET, any .NET library I can access in my FSharp code. So the advantage of being based on standard platforms like .NET or JVM is you actually don't have to worry about that part. Even if somebody has a Java code in it, right? Because Java being standard, you can use it on any JVM-based language. Somebody has a C# or Visual Basic or whatever VB.NET code, I can use it in my FSharp and vice versa. Alright, so FSharp is a multi-paradigm programming language. I've already covered that part, so it's predominantly geared towards functional programming, but you can define objects, classes, you can define mutable variables. Generally, it is discouraged to define mutable variables, and I'll explain what mutable variables essentially is variables that you can change the value. Remember I said the data is immutable. So by definition, FSharp, when you define a variable, it's immutable, but there are constructs that allow you to define a variable that you can change later on, pretty much the way CSharp does. It's not something that is generally recommended, but in cases where you need, you can. And for most of the people who are new to FSharp, they migrate from CSharp. If you go and tell them, if you define a variable, you cannot change the value, they get scared. They're like, how am I going to work? So it makes those transitions easy for those people too. It runs on top of .NET platform. It has an inbuilt type inference language. So FSharp is actually part of what is called as an ML family of languages, which was developed in 1970s. And the primary motivation for developing ML language was used for symbolic computations in automated theorem proving. So I think it was developed in the University of Edinburgh in Scotland somewhere in the 70s, and it stands for meta language. And one guy was Robert Milner, and I don't know what the second one was. They developed what is called as type inference that says sorry?
Indley and Milner.
Okay, yeah. I don't remember the names. So, yeah, and they have this, they have an ugly mirror, the type inference system, that's right. It says that you don't actually have to explicitly declare the type, the compiler can infer by itself. So it's pretty much similar to, let's say in CSharp you have the generic program, right? You define your types as generic variables, and when you use them, the compiler actually creates an instance of those functions for those specific types. FSharp actually works somewhat similar. You don't have to declare types. There are cases where a compiler would not be able to infer the type, so it actually will give you a warning. Like if you use Visual Studio and it cannot infer, like I don't know what type it is, it'll actually tell you in there if you are required to declare an explicit type, but that happens actually very rarely. For most of the part, you actually don't have to declare any types for it. It's cross-platform, so obviously being .NET, it's available on Windows. Project Mono actually is available on Mac, Linux, and I think Microsoft has another one, they call it Core CLR, which, so about a year or two ago, Microsoft announced that they're going to officially support .NET on all platforms. So I think they call it Core CLR, right? Which is their version on Linux and Mac. And Mono was an open source that was developed in early 2000 when Microsoft was not supporting Linux. That was the time when Microsoft used to hate Linux, not anymore, probably. Another advantage, you actually have a fantastic IDE and tool support. I don't know about you guys, but it actually helps me be really productive. Visual Studio on Windows, by far the best FSharp IDE you could ever have. By far the best IDE for everything, actually, I'd say. On Linux, you have Mono developed. On Mac, you have Xamarin Studio. You also have, I think, Atom Editor has an FSharp mode, and there are a couple of IDEs here.
There's something called Ionide.
Yeah, Ionide is actually a plugin for Atom Editor.
Atom and Visual Studio Code.
Yeah, Visual Studio Code is a cross-platform that Microsoft. So I think it's not. I mean, they are working on it. It's obviously not at par with the Visual Studio on Windows, but hopefully at some point in future it will be. But nevertheless, even on Mac and Linux, IDEs are pretty good. Like I use Xamarin Studio on Mac, and it's like one of the best IDEs I use on Mac. Okay, so this is what I mean by declarative style. This is by the way CSharp.
Got a question, or should we wait to the end?
No.
So, if everything is immutable, or in theory it's immutable, what's the memory model when you're running a program? Is it like just a lot of memory because it's storing all these variables? And you're creating new ones all the time, or is it? I guess it all depends. But
I don't really know the exact answer because this is more of how you implement the compiler. I would somehow think the compiler would have some kind of translation mechanism because at the end it's running on a manual and architecture machine, right? So behind the scene, yes, compiler would probably translate this into some kind of memory model where you can mutate. But the thing is, that's compiler's job. You as a programmer don't have to worry about it, right? Now, I understand someone coming from C++ background would have a little bit of a hard time digesting it.
Yeah.
Like, how am I going to use it? I had it too. Once you start using it, you get used to it, and then you start thinking. There are certain things like loops, etc., that are, when you talk about programming, it's actually you have to change the way you think. You're fundamentally going to a different paradigm, right? So if you look at it this way, that you have a data and you have a series of manipulation on that data, then think about it this way. Think about the pipeline. You have a data, you're doing a series of transformations on it. So you're building functions. Now you will see, okay, I don't need to change the data, right? I just have to change these functions in such a way. Like think about, okay, I have an input, I have an output. My input comes, I have a function f1 that translates that input into some intermediate state. I have another function. So I can chain these functions, and whatever input I get an output corresponding to it, right? That's the way you think about it, and when you think about it that way, you realize you don't have to change the input. Now, in real life, you have I/O, right? So there's a little bit of interactive, and in that cases, you do actually need a little bit of mutability. That's probably the only place where you need it. And that's why FSharp is actually not a pure functional language. Now, if you use something like Haskell, they have a different mechanism called monads, which is way too complicated. I don't know much about it, where they deal with such cases. But in FSharp, you do have mutability mostly on I/O cases. But general logic does not require mutability. It's when you think about those programs, think about it as data transformation pipelines, and then it makes sense. And generally, most of the FSharp code, like if you learn the language well, what it tends to have is you have the pure part of the language and then you have an impure part. Generally, professional programmers would not mix the pure and impure part. They will have, okay, this is my I/O module where I have all the side effects and all the mutable states, and this calls function, right? So my input, I call a function. The function itself might be pure. When I write my FSharp code, I rarely ever have a mutable state other than an I/O. I might have some log statements printing, and that's the only side effect my pure code would have is log statements printing. But no, generally, the way language is defined, you actually don't need. When I look at some of the samples and you see some of the filters, it actually becomes a little more clear. Right now, it's more of a theory thing, so it might get confusing. But okay, here's an example of declarative. Right? Look at the C# syntax above and below. You have a list. You have this as a mutable variable here, and then you loop through and you say if certain condition is true, just add it. And you have the same declarative, right? Start with this one, and this is your sort of a transformer or a filter. So take this input, filter out all those, and put it at the output, right? So this kind of is a very small example where you're saying you're avoiding that mutable state, and you have replaced it with a data transformation pipeline.
Both codes are not equivalent.
Sorry?
Both codes are not equivalent.
They're similar, not exactly the same. But
No, not the same. Because on the lower line you have iterator. You have to transpose it to the list.
sorry?
You need to add the transposition to the list, like dot to list.
You mean the syntax is an issue?
No. It returns the collection of something, not the list.
Okay, yeah, I got it. So you could cast it, I guess, to listen, that would solve the problem. Yeah, but this was more of an example of what declarative code is. I'm not going to go into syntax. But yeah, you're right. If you use such a code example in FSharp, actually you would not have an issue because the type inference is going to do that for you. See, this may not be clear what type it is, but when I use this VIP customer later on as a list, the compiler infers that this is a list. So it actually will automatically transform for you. That doesn't happen in C#, it will happen in FSharp. If this was a pure FSharp code, you actually don't need to cast it to list. Okay, so this is the imperative, this is the declarative. So this is what I'm talking about. Immutability. If you declare a function as a variable let x equal to 1 and you have the C# equivalent, they are not the same because this F# would not allow. Once you declare a value and F# basically doesn't call it a variable, it calls it a value just to differentiate itself. So this is a value that you're binding, but x is a value from 1. You're not allowed to do that. You could do something like declare another variable, sure. Now, if you declare it as mutable, right, then you're allowed to have the syntax. And note the operator is a different one, right? That's not equal to. So, this is the assignment operator in F#. And you're allowed to do that because you're explicitly told that I can mutate this variable. Okay, so as I said, it's a functional language. So functions are the building blocks. The functions are treated as first-class values. So what is a first-class value? Basically, functions can be used pretty much the same way a variable can be used in a normal language, which means you can bind it to an identifier, you can store it in a data structure, so I can have a list. Actually, nowadays, even C++ and all these languages actually does support a lot of functional paradigms, so you probably would be able to do that in C++ also, I think. And lambda functions are supported in Java and C#. But otherwise, by definition, you could store these functions in a list, you can pass them as an argument, you can return them in a, essentially you can treat them as values that as like variables that can flow in your program. You have structured way of storing the data, you have tuples, records, discriminated unions. Tuples and records are actually pretty similar. Discriminated union, I'll talk a little more, but they have some interesting properties also. So again, this is a C# code and you'll have the corresponding F# code. It's pretty simple what a tuple is, right? So this is a tuple in F#, A, B, C, that's the syntax. You don't need to declare the types because the compiler will infer it for you. So that's how you declare it, that's the corresponding F# code, right? You can pass it and standard F# library would say try pass, it will have a success boolean variable, try and I think if you fail, I don't know, random value might be some random value. There's another thing called options actually for this case, but we'll talk about that later on. Okay. Records, the C# syntax, the corresponding F# syntax. So records is what C++ or C struct is, pretty much. You have basically data stored and you have a field associating having a name for that kind of data. So you cannot have this because it requires both quotient and remainder. You haven't supplied. The F# compiler says this is a problem. You could have something like new result. You could have something like these are ways of declaring. And the important point here is that when you compare them, you're actually looking at the structure required. That is to say that these are not classes, because if you have something like Java or C#, when you compare, you actually compare the pointers. So even if you have the same value, it will say this is not equal to this because these are two different objects. When F# compares it, it compares the value. So that's what it means by structure equality.
So from this, you have a type division result. So I guess it's inferring based upon the values of quotient and remainder.
That's right.
So okay, I got a division result.
Yeah, that's right. So it says 3. If I say 3.0, it now infers this as a float. So based on the value, it will actually infer it. And again, it answers the same thing. Even if I don't declare it as a list, if let's say I define x equal to something, some number, and later on I use it, it actually can infer it. Okay, this x variable was used this way later on in the code, so it must be of that type.
You can never have something else renamed with a quotient and remainder. It would have to be always be division result, right?
Yeah, that's true.
There's a deep copy either, or deep comparison. That's what you were saying.
That probably. It's like comparing the values and not the actual pointers.
But what is the value? Because
Because
it can be
Values
it can be a structure. You know, each field can be a structure. And then as it goes deep, eventually add values.
It will go into recursive mode and say, okay, fine, this is the definition. So if you have a struct of a struct of a struct, actually will go recursively.
So it's really a deep comparison.
It is a deep comparison. Yeah. So this is called as discriminated union. Actually, the syntax has changed a little bit from FSharp 3 to FSharp 4. So if you're using Visual Studio 2013, this is not going to be supported. 2015 we have it. That's why, sorry, 2013 supports this, not this. Yeah, 2015 we have both. That's why I actually kind of differentiated. Discriminated unions essentially, how do I explain? It is kind of a set of tuples with some tags associated with it. So you would have, okay, let's say some kind of relation, father A comma B, A is the father of B, mother A comma B, son A, something like that. So here you have like a division success. When you see the code, it becomes more clear. In FSharp 4, what they have added is they've allowed you to name these fields, whereas in FSharp 3 you're not. So when you define a variable, let's say let x equal to division success 3 comma 4, in FSharp 4 you can explicitly say let x equal to division success, quotient equal to 4, remainder equal to 3, or vice versa. When you use this syntax, obviously you have to declare values in the order in which these are defined. So if you say division success 3 comma 4 means quotient is 3, remainder is 4.
Now, mean that in FSharp 4.0 you can name.
Yeah, you can name you can name those individual fields. Yeah, this is a new feature that they've added in FSharp 4.
And so those are sort of records instead of tuples.
Yeah, actually,
So this FSharp 3.0 like tuples.
yeah, so think of it this way, so they are kind of a collection of records than actually a record. Because this is one type. So think of it this way, this is a collection of record, one collection, say one name is division success, other name is division.
It's two records.
Yeah, it's two records combined into one type.
Right.
So your division result can have a value of either one of the record. And once you have it, you actually can pattern match, which the next slide.
Again, this is an inheritance structure.
Yeah, there you go. You look at the C# code, that's actually pretty much what it is. So that's why I had the C# code, so sort of gives you a context of what it is. All right. So we have defined a type line, and I say, I can have line. This is the FSharp 3 code just for compatibility. I have the old code here. Line center, and it has different fields. I actually can do some kind of pattern matching. So I have this length variable declared and says, well, if you have a fill, then I just care about the line fill prefix and suffix plus 1, so on. It doesn't really matter what these actual values, but what I wanted to show was you can actually match. So these are these patterns, and you can have this match syntax that actually can be, if it's of this record, that's the value. In this example, I have explicitly declared Z as line, but this is actually kind of optional because the compiler can infer it. So these names are unique, right? So when it says you're talking about line null, line fill, it actually says, oh, this is of the type null, so Z must be of the type null. It can infer itself. And if let's say I forget one type, I just miss this line. If you go to Visual Studio, it won't actually compile the code because it says one pattern is missing. Right, because you have like a set of 5 records. So if I'm doing a match, what if it's line to str, right? You could have something like a syntax that says underscore, which means if it's none of the above, use this one. So think of it as C++ struct case, right? You have defined a structure, and if it's case 1, case 2, and then you have a default, if none of the above, use this. So FSharp compiler, if you define a type, you actually, in any match statement, either has to inherit all these record types for any match pattern matching, or you declare a wildcard and says, it's none of the above, do this. So I can skip these 2 lines, and I say underscore -1. Right? That's valid.
But switch is based on values, not on types.
Yeah,
you can use reflection and
yeah. I mean, I wanted to contrast switch as set of case space, so pattern matching is something similar, but it doesn't translate exactly as switch. If you use Swift, or if you use something like C# instance of, then if you look at this code, it will be something like, okay, if it's the instance of division success, then cast it into division success. and extract these values. You can do pattern matching in C# like that. So here it's providing you a syntax to do that automatically. You don't have to typecast and convert and all these things. A typical example of a function definition, you would see some piping operators, pretty interesting stuff I'll cover later on. But so you have this function generate that takes the two variables b and target. You're not specifying the type, the compiler would generate it. So you have intermediate values and functions declared, and then you have this max at the end. So when the function returns, this is the return value there. It's max. And you do have side effects here because it's writing to a file. So this is how a typical FSharp function would look like. It will have some intermediate definitions. It might have some side effects in it, and then it has the return value at the end. Questions? Okay, and I'll explain what these piping operators are later on. Okay, so let's talk about the types. So I have those expressions defined and I have their types corresponding. So add1 is a function that takes one value and returns one value. So this is its type. It takes an integer and returns an integer. Add xy takes another integer. Now this, I'm going into a little bit of complications here, but there's a concept called currying in functional language. So think of it this way, that integer, this is integer, I don't know how to explain it in the last. Any function xyz can be thought as a function that takes one parameter, another function that takes y and z, and then function that takes y and z can be thought as another one function that takes y and another function that takes z. In other sense, what this is going into a bit of a mathematics here, and I don't think you need it to use FSharp, but just to give you a bit of a context here. In mathematical theory of functional languages, a function can only take one parameter, and you combine these functions and you call it currying, and they have a concept called closure. Again, I don't want to go into the details. So the notation is actually coming from there, but let's stick with the programming world and not into mathematics and say that this takes one integer, takes another integer, gives you that integer. This takes a type A. A is a generic variable. It doesn't define which type it is. Anyway, and takes unit. Unit is what you would have as a void in C++ code because it's not returning anything. So again, this is taking a unit because the function doesn't have any input and returns back a string. You have a list. So in C# world, think of it this way as list, and then you have the angular brackets and type A, right? FSharp writes it that way and returns to you another of the type P. In this case, some would be used for, let's say, integers floating points. It takes a list of integers and returns to you another integer, or a list of floats and returns to you another float. Filter takes a function, right? And we talked about higher order functions, so you can have one function combined into another, make it, you can pass functions as values. So here you see that example. It takes a function that takes some generic variable and returns true and false, takes a list and returns another list. So let's say an example of list filter would be, I give you a list of integers, right? And I write a function that says if x is greater than 5, return true. And if it's less than 5 or equal to 5, return false. And I pass these to list filter. It will filter that list and gives me all the variables for which this function is true, which in this example will be all the numbers that are greater than 5. So that's how list filter is used. But this is what I mean by the function having a first class value, that you're passing it as a parameter just like you would pass a variable. You see the same thing happening here. Map, for example, I can define a function that takes a string and gives me back a number, let's say the length of the string. And then I pass this function and I give you a list of strings and I get a list of numbers back. So I'm passing a function, I'm passing one list and getting another list. So this is how FSharp defines its types. If you use Visual Studio, you actually have commands that when you declare a variable, it actually tell you what type it is, and you will see that syntax for what type it is. Questions? All right. Partial application. So this is again an example of higher order function, how you can combine small functions to build bigger functions. So you have, okay, some AP result some 1, 2, which actually is equal to 3, so that doesn't get surprised. Then you have something like result sum 1, which means, now if you remember that syntax, it takes int. The type of this function is int to int, because you've already supplied one variable. So you have created another function that basically takes a variable x and gives you x plus 1, because you've supplied the value of a to it. So this is called as a partial application. Again, in functional programming, you will have these complicated terms like closure and all those things that when you pass these variables and you complete the function, you obtain what is called as a closure, but I don't want to go too much into the functional programming. What I wanted to illustrate here is you have taken one function and created another function from it. Right? So this type was int to int to int. Now you have int to int. And if I say result x or result 3, it will give me 4 as an answer, because it's adding 1. There you go. This would result 3 plus 3, because 2 plus 1 is 3. Same thing. Composition, you have a function, let's say f takes an input x and gives you a value y, and you have another function g that takes y and gives you z. You can combine these two functions and say you have another function. So what it happens is take x and you get z back. So, sorry. So this is called as composition. It actually will take a plus 1, and this function will say a plus 1 plus 2. So if you supply a as 1, it will actually give you 4 as an answer. This is the piping operator that you saw in that example. And what piping operator does, it essentially think of it as a data pipe. So you have, like I talked about the transformation, right? So you have data, then you pipe it to the next function, so it kind of passes that data. So I'm going to start with numbers, and I'm going to have a filter that takes a function which returns me a boolean, right, of all the variables where n is greater than 1, and then I have another filter. So I can actually define multiple filters. For those of you guys who know CSharp, you would find it very similar to LINQ. So actually, to give you a history, the designer of FSharp is the same guy who designed the generics and LINQ and all those things. So they actually share a lot of syntax with each other. But LINQ actually comes, and SQL actually has also very similar syntax, right? SQL is actually very functional in that aspect. That I select a row, I apply where order is greater than 1, where some field is less than, so on, so on. So you have a filter. You can actually make pretty long and complicated filters, and it shortens up the code. If you see that code example of that big function that I talked about here, you see what I'm doing. I'm saying I take p, I apply this function SNT, which actually takes second, combines all of them, lengths them, and take the maximum length. So think of it this way, that if I have a list of tuples with the second value as string, what this in one line is doing for me is it's combining all these values into one string, taking their length and giving you the maximum. So the data is flowing from one file to another file. Questions?
I have a question. When you're talking about ends, does it only go up to the order of 3, or can you do ends like up to 4 times?
There's no limit.
There's no limit. Okay, I thought there was a limit of 3.
Sorry, where?
Yes, over there, the second line, the let's add x, y equals to x plus y. Can you do let's add x, y, z? Or does that have to be? Okay.
No, because that's the maximum.
That's the max, that's the question.
So this, in functional language, they call it closure, right? So when you're building one function, right, you have a maximum parameters n defined. You can only go up till n, because can't go n plus 1. Now, if this was derived from another function that takes more than n parameters, you could do that.
You could write add x, y, z equals x plus y plus z, and it would be int to int to int to int. Like four different.
Okay.
So when you complete this chain, you say, I've obtained a closure on this function. That's the term we use. Right? So if you read the functional programming literature, they have like a lot of terms that sounds a bit confusing to an average guy, so I tend to avoid it.
So when you have this add one function, and sum, the next one.
This one?
Oh, go back a little bit.
This sum.
The other way. Sum. Next one. Next one. Add one. Okay. So this sum one. So is the one in closure? That's how you say?
No. In this example, you don't have the closure because you still have closure will be obtained when you remove all of these. So let's say I define another value that says 2 equal to add 1 3, then you have obtained a closure because you have closed this chain into a value. So this is not a closure because you still can have one more parameter here. Used.
Yeah, but the one is enclosed into the closure. That's what I.
Closure.
It's partial, but not even.
It's not complete. Closure is when you complete the partial. If you haven't completed, you still have one parameter. So that's why it's not, you haven't obtained a closure here. You have obtained a closure now. Yeah, this is again a closure. Okay, composition that you have covered. That one, pretty simple. You just, so composition and piping actually, they kind of are, you can use it interchangeably, right? Piping is generally a more common thing, but sometimes composition can lead to a shorter syntax. So we talked about pipelining. All right. So yeah. So that's how think about pipelining that you have. You can also define a composition function here, like h double bracket g double angular bracket f and then plus x. Same syntax. Options. So options is basically, options is a discriminated union, but it's a predefined discriminated union that you have, and it actually in CSharp there is a horrible thing called null. And everybody has encountered that situation, right? And what happens is sometimes you don't have a value. So I call a function and I can get a value, or I don't have a value, in which case I could do null. And you have to explicitly check null, and if you don't do that, you're in for trouble. So FSharp defines this discriminated union that says you have some or you have none. Think of it this way, that you have a value or you don't have a value. So in certain cases where I'm expecting a null, I'll actually define an option, and then I can essentially have a pattern that says, okay, if there is a value, do something about it. If there's no value, null about it. So what it does is it avoids that null pointer exception problem a lot. Everybody hates it. I think one of the worst things about C#. Yeah. F#, I think this is more of, I don't know, F# 2 did had it, F# 3 and F# 4, they actually define this thing called units of measure. So you can add these values. For example, in this case, this is a valid code which actually should not be valid. So I have distance in kilometers and I have distance in meters. So I can actually define something like a measure and type these numbers, and if I do that, then FSharp compiler will say, well, you cannot compare them because you measured. You can define your own conversion functions, and once you do that, FSharp would accept it. So in a lot of scientific programming, units of measures is something really useful. I love it. The scientists love it. All right.
The scientist's version of type safety.
Yeah, it's a scientist version of type safety. It's actually it's pretty handy if you think about it. If you're developing like physical models and so on, right? It actually can make a lot of things. All right, so same thing, you see unit of that doesn't match, so now you can convert it. Once you convert it and You have the function, the units of measure map, this is valid code. Okay, so FSharp collections, arrays, list, and sequence. What's the difference? Arrays are mutable, lists are immutable, and sequence are lazy list. I'm going to explain. Arrays typical, actually, sorry, this actually is wrong. This should be here actually rearranged. This is the list and this is that. So
We made that right, just in the other order.
yeah, the order messed up. So this is pretty much the C-sharp array that you know, right? You can reference them as element 1, 2, 3, 4. Let's go to the next slide. Yeah, order. So you have these arrays. I can say I can index them and I can mutate them. Arrays are mutable, and these are various ways in which you can these arrays. So you have a yield syntax, kind of does this. So this is basically an array of tuples of the type int, comma, int, comma, int. That's how FSharp interprets it. Then you have the list. For those of you who have used list or prolog, it's pretty much the same thing, list, there. Basically it's a linked list, right? So you cannot reference it by index, you have a head and tail syntax. So pattern matching can do that. Pattern matching would have like match x into the syntax is, can I actually write the syntax here? Yeah, so it will have, I can write it. Maybe I'll have an example at the end. So pattern matching, you can have a head and tail, right? Or it's an empty list. But otherwise, you have these filters that you can define. So again, you have instances where data is thrown in the list, and you could, have all kinds of mapping function and filters and so on. So FSharp has a huge collection of different ways in which you can form lists, right? And these are all the modules. So you can have filter, map, fold. The reference fold is actually in some case. Sorry.
Can you come back to the previous slide? On the right side, you have a filters and a map. And you mentioned the data are immutable. Does it mean that filter produces his own list of data, which is consumed by the map?
Yeah.
So every stage produces their own sequence of the data.
Exactly. It's not modifying the previous one. Behind the scene, think of it this way, that this is actually 3 lines, right? So you have VIP name is customer, let's say X equal to list filter of customers, and then you have Y equal to list map of X. So behind the scene, that's what the compiler is. This is just a shorthand filter, so you can spike the data, right? But it's still immutable, because
So for example, we start with the list 1,000 of customers.
Yeah.
And by applying these filters, we cutting out, let's say, to 100.
Yeah, you're getting a new list.
So I get the new list, 100.
Yeah.
And I'm passing 100 to the map.
Yeah. Okay. Exactly. So you're not mutating the customers. This is still immutable code. So you have all of these, whether something exists, you can partition, you can zip, so you can have 1 list and 2 lists, and you can take the Cartesian product. It's actually used when you have multiple loops, right? For A is equal to 1 to 10, for B is equal to, you'll encounter that situation, right? So you can take the Cartesian product of these 2 sets and then pass them in list.fold. List.fold actually is kind of a loop, right? Where you have a state. I'll since we have internet, I'll actually I'll show some example of list.fold. Actually, it's hard for me to explain, but we have the link here. Okay. So FSharp Sequence is kind of the same thing as list, except it's a lazy list. That is, it's only computed when you need it. Otherwise not. For those of you who are familiar with Haskell would understand what lazy list is. But essentially lazy list is an expression which is only evaluated when it's needed. And particularly when you have very, very, very large set of data, and let's say I have like 10,000 customers and I need first 5 customers who satisfy a certain criteria, I'll use something like a sequence. So as soon as I have 5, I don't want to compute the remaining 10,000 or not 10,000, let's say million. So that's where lazy lists are used.
One other point that's interesting in pipelines, it will will actually do one through the pipeline. It won't compute a sequence for the middle of the pipeline. It will only compute each lazy step. So if you want to avoid intermediate lists, you can use a sequence in the middle. Basically build up things and then only end up with one output list and one input list, but use a sequence in between. And so that avoids allocating that extra customer list or whatever it is, and that gets rid of a lot of allocation in some cases. But since it's lazy, there's a little bit of overhead, so you need to decide whether you want to avoid intermediate list allocation and extra hoops through the data structure, or if you want to go very quickly through the data and be able to process fast and keep things in cache and have very little indirection. It depends what the balance is.
Because when you have a lazy list, you're carrying that expression that is already carried in the generator function. So if in cases where your elements are small, you don't want to carry that function, it's actually generally better to use list where you know you're not going to consume all the data, you only need partial amount of data, or you're memory cautious, you probably would use sequence. So it depends on your usage. There are both pros and cons. Coming back to classes, our very favorite, because
Question before that. So why did you do composition? So you compose one function out of many.
You could. It's sometimes it's just more convenient to you. There's multiple ways of solving a problem, right? What makes it more convenient? You could, if you have a function available, but sometimes piping just makes more sense. I have a list. I'm never going to use that function again.
There is no intermediate.
Yeah, exactly. I have lambda functions, right? So if I have to use compositions, right, I can store these lambda into values. I can just pipe them. They're similar. Certain times it makes more sense for you to pipe them. Certain times it makes more sense for you to use the composition. It really is two different ways of kind of doing the same thing. All right. So classes, right? You have the C# code. You have the F# code. Kept it here so you could class it. You have the member, you have the property, and you have the method that says, okay, fine, I'm taking one parameter and returning you the value. Generally, F# does not have these curly brackets, so that's, I don't know, I find these brackets to be very annoying, so I'm glad they're not there. Same thing, now you have mutable fields. Because your C# classes, because your classes are the same as C#, you actually have the same level of support. So you do have the ability to define mutable variables. You explicitly mark them as mutable, and these are your private properties. And if you want to make them public, you can actually do it also by having them as member. And yeah, so you have the getters and setters here. This is the direct code translation. All right, so you have the interface. How you define an interface? You define them as abstract, and you have to give them a type. Now, here you have to give a type because it doesn't have the body to infer. That's the time when I need a type. So it takes one integer and returns another integer, and then you have a class that actually implements this interface. Type providers. So.
Back on classes, is that like in C++ objects?
Yeah.
So do you have like you get multiple layers of classes? Like
Yeah, you could do that. You could do everything that you could do in
Okay.
C#. Yeah, this is a one-on-one translation. If you have a C# class, you can use it in F# pretty much the way you can have this class defined in F# and have C# code use it.
okay, so one class could extend the other in a normal OO paradigm.
Everything.
Is that pneumatic F#? Because you're using like C# object-oriented principles of F#. Is that what you're trying to explain?
No, I'm just having a C# and F# code side by side, so it kind of gives you.
Okay, gotcha.
But obviously, if you're using F#, completely F#, that's meaningless.
Okay, gotcha.
Yeah, it's just giving you a contrast. Okay. Any more questions? Yeah.
Does he have like a type classes with the classes?
No. You don't have those type classes in F#. I do think that there was a debate going on. There is something like a computation expression, which is something, I'm assuming that type classes, you're talking about the Haskell type class.
Yeah.
Yeah. So there is something called computation expression, which loosely is a monad of Haskell, but a pure type class that you have in Haskell, to my knowledge, F#.
You can emulate it with something called static constraints, but I don't recommend using it like you would a type class in Haskell. If you have questions about that, I can show you after, but this is how arithmetic operators in F# are implemented. If you notice the example with integers and floats use the same plus and divide, in OCaml, for example, you'll notice they have separate float operators. The difference there is F# is using a special thing called static constraints on inline functions, and I can show you how that works after.
I know there was a debate on adding type classes to F# because they both come from Microsoft Research. So, Peyton Jones was talking to Dan Stein, but I don't think it's there yet. You might see it in future versions. Any more questions? Type providers. So what are type providers? Type providers are essentially ways for you to find data from different sources. Our world is filled of different sources of data, and you have these F# types, right? So you can have data coming from SQL, CSV, JSON. There's a whole bunch of type providers. This is a list of type providers that are predefined, many more. You can define your own type provider. I'm not going to show an example because I don't want to go into that much of details right now, but if you search online how to define an F# type provider, you actually would see. Just as an illustration of what a type provider is, I'm using a CSV type provider, so it actually can infer the data and has the name and credit that you can print. So you have a sample CSV, actually you could load it to print the name and credit. It infers it on its own. Yeah. Okay. Towards the end, I have resources if you want to learn more about F#. Questions?
Yeah.
Okay. I can email you this.
Oh, perfect.
So F# is actually the main website, F# Consortium. They moved to open source. You have a try F# where you actually can learn F#. You can type F# code in the window and it evaluates it. Another website is F# for fun and profit. You have these different books. So Don Syme is actually the creator of F#. He works at Microsoft Research. This is more like a it's a reference. It's good because it's concise. I like such books. I don't want to read a book that explains one chapter on what a for loop is. So if you're familiar with language, I recommend this book as one. But if you're moving from C#, you have another book, F# for C#. So it kind of gives you a contrast of how to translate the C# and all the design patterns. There's a book on real-world functional programming. So this is more geared towards functional programming than F#. So you would have an example of, I have C# code, I have an F#.
No, never mind.
Okay. And how to use them together, because a lot of times, especially if you're using something like a user interface, you generally might want to use F#. C#. Part of the reason is we have XAML and all those things supported, right? In C#. You could do F# also, but I just think the GUI world is much more developed in C#, and somehow the way user interfaces is it's very state-based, so it actually links very well with an object-oriented model more than a function model. But anyway, so this book actually covers examples of C# and F# and how you can use them together. You of course can use a bit of functional programming in C#. Most of the languages as they evolve, they borrow features from each other. I know Java 8 has lambda functions and all these things. Beginning F#, you have a book that actually is more for beginners than for experienced people. You have another book. This guy also used to work for Microsoft. I think he left for Google a year or two ago, but he was in the team that uses that developed the F# language. Thank you. Questions and any other topic you may want me to go into details, I can do now.
To answer your question, you talked about changing how you think when you're programming functionally. Like, let's just say if you're using F#, you're thinking in a functional way. how do you actually start? Do you start with like defining the type or the function? Because in object-oriented programming, you start by the classes. Like how do you start with
That's
functional
right.
programming?
So
Right?
when I said functions are the building blocks, just the way classes are,
Yeah.
that's what we would do. You define, typically what you have is you define your set of functions and you define your types, right, enclosed in a module, and then you have a main function, which is pretty much like the main of C++, right? And actually, I could, maybe now that I can actually go to, we would have something like Safari here, right? Yeah, so I can actually then go into some kind of examples, maybe. Be a good idea to go into examples of FSharp programs, or maybe I can download.
Let's try FSharp. I also have like Xamarin Studio, or you can do Windows if you want.
Well, I think let's learn FSharp examples. I just want to show you some actual FSharp code. So this is where you have the main function, and then typically some like project. So FSharp actually can be used interactively as well as in a compiled mode. You have what is called FSI, FSharp Interactive. Even C# now actually, Microsoft has released the C# Interactive, right? For those of you who use some, like let's say Python also has an integrated mode, and you can run it in a shell script. FSharp also has the same. So you have these various directives. Load the DLL file, load the file, and so on, and you can run FSI. Let me see if I can. I should have it.
FSharp.
I think it's on Windows. It's So you have
may
to
want to increase the font. Command Shift plus.
Command Shift plus. Okay. So. Okay, there you go. So I've defined a function. So when you use the interactive, you actually have to have these double semicolons just to tell the interpreter that you've entered a line. So it defines a new function that takes an integer and another integer, and that's actually, it should have been b. Yeah, there you go. And then I could say something for, I think it will just evaluate that value as 9. I want to show you how loops so I had mentioned about list.fold. Loops is actually the only thing in function C# that actually find it a little better understanding fold. So let's go to something like an example of
It's the same command class.
There you go. So let's actually look at the fold. So you have the type defined. You have matching on this type. This is a good example of fold. Yeah, there you go. Fold. So it takes all the directives. So list fold is kind of F# way of implementing a loop where you actually take accumulator, or let's put it this way, a state. You provide some initial state and you iterate over it. So Recurse is actually the function. New AC is the initial state, and then you actually have these did items and you calculate the new state. And this resub function takes actually the old state and the new state and calculates the new state. So this is the F# version of a for loop. I know it looks a bit.
We can show it in the interactive. I've got a good example we can try.
Okay, so
let's define a sum over a list. So,
okay. This, I could do something like. This is sorry. Okay. Pretty simple. Now let's put it this way that I want to sum them using for. Basically, I want to have some kind of for loop. So I start with initial 0, and I want to, as I iterate over the list, I want to add the number. So what I'm actually going to do is let add. I already have the variable sum, right?
actually, just Just do it with an anonymous function. It might be a good way to show that syntax.
So I'll say a pipe, right? List dot old. I define a lambda here. All right, and my initial state is 0. What is it?
Right.
Need a space before line.
No, I don't think that.
Yeah, I think it's
Right.
why.
Here.
Is that the reason? Yeah, there you go. So you're folding a list, you start with 0, and as you iterate through the values, you keep adding. So you have this 0 as what you call as your initial state, and this function that manipulates the state. So x is basically, I should actually
Put a print xy.
this
Oh
because
yeah, that might make it clear.
yeah. So this is it.
Put a print xy semicolon before the x plus state so they can see the call each time. So print fn or say a or b or something. You need 2 of them if you want. Not a, you want
X is so.
x and yeah, x.
So you see, these are the. This actually
I think you have state and
Yeah,
x.
sorry, my fault. Yeah, this is actually the right.
Yeah, sometimes there's both back, but yeah, that's correct.
Yeah, this is actually the values of the list, and this is the state. So fold is yeah. So now it makes clear what fold is. I could have something like, now I can pipe in and say I want to sum all the lists that are even. So I just say all the numbers that are even. So I say filter 1x x percentage here equal to 0. I think that should do the job. Yeah. So what filter does is for all those numbers that are even, that is when you divide the 0, you have 0 remainder. So it takes a, filters out all the numbers that are
Just print a again.
yeah. What I'm actually going to do is I'm just going to show you the intermediate output, and that is left equal to, and then I'm just going to remove the fold, so you get to see what these intermediate values are. So it filters and gives me all the even numbers, and then I actually use the fold to sum them 6. So that's how I can do filters, I can do fold, I can do the same thing with arrays, and I can do the same thing with sequences. More questions?
I don't think you can. What's your data access layer? Because I was having a conversation. Somebody said they use type providers, but if you're trying to extract data from a database, do you use like SQL providers or like?
You can do that. See,
in your experience, which one is actually more faster or like best practice?
Good question. I haven't particularly used SQL providers, but I think if you have a custom query, you probably want to use a SQL query, right? Because what type provider is doing is getting a data, right? Fetching a data and putting in a type. And then the filtering and ordering and all those things you're doing on the FSharp part.
Okay. Yeah.
Right? So the syntax might be more simple, but let's say if you're a huge database, and I don't want to do the filtering on fetch me all the data over the network, and then the filtering, I want the SQL part to just filter in between what it is. I would actually then pass the SQL command.
Yeah.
So that's where you have to make a decision.
Well, the query expressions in FSharp, it does send the filter to the SQL box.
Yeah.
If I have a type provider, can type provider do that?
Yeah.
Okay, that's interesting.
That's pretty magical.
Yeah.
It's just like Link.
And if you look into something called Embrace, you can do that with even more kinds of computations across machines. It's really cool.
Yeah. And FSharp does provide some. So I actually, now that I have time, I can just go into some of the libraries for FSharp. So if you go to FSharp data charts, it actually has very good charting and visualizing libraries. So you can have all these, predefined bar charts and so on. You can get data manipulated in the list, define it, charting libraries. You have something called FSharp computation expressions, which actually is the monads of Haskell, right? So something like this. So you have all these logs defined. You can just define your a computation expression. So each time you define a log, it actually gets automatically logged here. That's the computation expression. You wrap it in a logger.
Yeah, computation expressions are like do notation on
Yes.
steroids. You can do up to monad plus style interfaces plus custom stuff, and you can also combine two monadic things with the yield syntax and the let syntax. So you have something called async sequence, which is a really cool combination of asynchronous computation and sequence computations. It's a really neat example.
And let's see what else. CSharp has some. So it has some good examples. I shouldn't be saying this, but there are pirated copies available on net. I downloaded it, but please don't tell anyone.
But do you have the 4.0 version?
I actually do.
I got a copy. I like it. But yeah, give it a read.
Yeah. Secretly, I can pass you the link where you can download. I just don't want to put it in a PowerPoint or have the camera. Yeah, offline. We can talk about it.
Press, John will watch
Yeah.
this video. I think he knows how to work that.
Yeah. So the book actually has examples on. So this is where we'll explain you type. So you have, because FSharp is based on .NET, you could have run FSharp code in Azure, which is what we do in at Jet. You have ways to deal with textual data. You have sequences. Charting I've already showed. Reactive asynchronous parallel programming. So you have a whole library of asynchronous and parallel programming and so on done. This book actually, I should have talked about it. It actually specifically tells you how to build FSharp solutions for mobile and cloud. So it obviously assumes that you know some FSharp, right? So it's building ASP and takes advantage of Azure and so on. So that's actually another book I should reference it. I think you get a PDF also somewhere. You can search for it.
Is this completely without JavaScript? You can do it?
Oh yeah, your ASP, right? As active server pages. So it's you don't need. You could possibly embed JavaScript because actually active server pages is dynamically generating HTML pages. So there's nothing stopping you from embedding JavaScript.
Okay. You don't need JavaScript.
You can always add something more.
Yeah, you can always add.
I'm just saying that without JavaScript.
Yeah, you could do. You could, because you have it dynamically generated based on user input, then you can eliminate the need for JavaScript for a lot of reasons, right? Because you can modify it.
I have it more like a general question. How long are you dealing with FSharp?
How long, like in Jet?
In general?
Like me?
Yeah. Thank you.
I learned FSharp about 2-3 years ago from Microsoft Research. I was working at Microsoft. It was more of like, unfortunately, they don't use FSharp internally for a lot of their products in the product division. Part of the reason is because they have a huge C# code base, right? So
there is the second part of the question. Usually when you start dealing with the C#, you probably need to use like I don't know, like 10 or more different design patterns.
yeah.
We know what is design patterns. So do you use that kind of similar notion in FSharp, like a kind of approach for handling a more bigger code base?
There's actually a very good reference that I can point out, and that reference is FSharp or C# because it exactly answers your question. And if you go through this book, it actually has the FSharp code for the translation. So this is what you're talking about. You're talking about
Okay,
design
we can go to the box, but I'm more eager to hear your feeling, how you handle this kind of code base.
Haven't used a lot of design patterns, but then the way functional programming is, it eliminates the need for those design patterns, right? Because
So for example, you have a system which will have, I don't know, thousands of lines.
Yeah.
So you just keep writing functions and hoping they are well designed.
no, because I can define higher order functions. So I will use these functions, define them once and twice, and there are functions that combine these functions into more. So in a way, see what a design pattern is some kind of meta-programming framework. But because I can combine functions into higher order functions, I eliminate the need for that meta-programming because the language has the ability to do it.
Okay. So there is only one design pattern which is a higher level function.
I haven't worked with a lot of design patterns myself, so I'm not really sure if I'm qualified to answer that question, but I do know in general, reading from FSharp, that it eliminates the need for a lot of design patterns because the language has the ability.
The design patterns you tend to see tend to be computational flow and structural, the algorithms, and a lot of those, if you really want to give them a name, tend to be things from category theory. You just don't tend to need to name them all the time because they fall out pretty obviously and they're easy to reason about in small pieces. So you don't need to always say, oh, this was a monad and that was a functor and that was whatever else, you know. So sometimes you do see those names, and sometimes we'll use those. Even at JET, we'll have things that are named after their category cousins, but the idea behind that tends to follow from just some domain-specific application of that library. Like if we're dealing with asynchronous data, we'll use words that are familiar to asynchronous programming models. And there's not a lot that we can borrow from the design patterns book on how to handle that any better than FSharp already does out of the box. So you don't tend to see visitors or observers or all of those things. Anything that comes from .NET, perhaps event programming and all of that is very well supported in FSharp. You just don't need to name a pattern to use it.
So for example, there is like a modern trend to use dependency injection or inversion of a control.
So dependency injections are a very good example of where the functional programming simplifies this vastly. So the currying example that was shown is interesting because what you can do is partially apply a function. So you have a function that takes 4 arguments, but the thing that actually wants to eventually call the function at the end only needs to pass 2 of the things and doesn't know about the other 2. What you can do is partially apply your function with the first 2 parameters, which can be your external dependencies, and you're injecting them via partial application and passing that query function into the final caller who thinks it's just a function that happens to take 2 arguments, but really you create exposure over those dependencies. And this just falls out of natural functional programming code. You don't have to create a dependency injection container or any of those things. It's just a function like any other function. And it's a feature that's just automatically there by using currying, which is the default. So a lot of these things do sort of get out of the way. That doesn't mean you never have to think about architecture, or you never need to think twice about how you structure your code to make it obvious what you're doing. But yeah, it becomes more obvious once you get used to it.
So what we are saying, and I'm trying to have a feeling, it is like let's say, object-oriented approach creates so many problems which they need to be solved by design patterns, and those problems just doesn't show up in the functional world.
To a large extent, yes.
Yeah.
I think actually was a statement from Peter Norwick, who's a director at Google, I think Google Research. He was talking about Lisp, and he made that statement, but I mean, I would say to a large extent it's applicable to FSharp also.
Remember that those design patterns are basically elements that let us reuse code to manage state in a class.
Yeah.
And with functional programming, because of immutability, you don't have to manage state. So probably one of the patterns that maybe gets used would be like factory pattern, because you're returning a new you're constantly using a new copies, objects.
And
Pretty
also,
implicit though. It's really implicit though.
Yeah, in the language, implicitly.
and also because you have the ability to create higher order functions from smaller functions, which is not there in object oriented, right? So essentially think of it as pattern with some kind of stubs for your own code that you plug in, right? Mm-hmm. And you can create that functions that take another function as a parameter. So you really don't need a pattern.
Or even a function that returns another function. Like when does some work to do some setup, and then just returns another function with like the work that was done, essentially the resulting thing for the work that was just in this closed over returned function, and it looks just the same as if it was queried.
Exactly. So you don't really need the design pattern for that things. More questions?
What should you not do in functional programming?
What should you not do?
Well, you had,
How does it have
you
to
had why
have
FSharp is good, why you should use it, why shouldn't you use it? What are the conditions?
Okay, nice.
Okay. If you want to phrase it that way, if your code is by definition something that is heavily used in state, probably FSharp is not the best solution. For example, in certain simulations, right, you have defined states, especially UI. Let's say you're defining a UI, right? By definition, you have a state. So it's like you can do everything that you can do with CSharp and you can do with FSharp and vice versa. But problems that involve a state will be better solved by CSharp, and problems that are more functional, where you have more of code reusability and buildings, more symbolic computation kind of problems will be better done than FSharp. So if I'm developing something which is very heavy UI oriented, I probably would use CSharp more than FSharp for that, because the state model actually lends itself very well. You could have certain simulations and physics, and you have objects and so on, certain problems where inherently your problem statement is like you have a state and you're manipulating. You might as well just use C# for that, or some very heavy I/O related program where you're almost all the time manipulating the state. Then what you're really doing is you have these mutable everywhere in F#, but you can do it in C#. Don't have to worry about the mutable states now.
There's ways to handle
The
that.
syntax may be shorter in F#, not? Or depends where you go.
F# syntax generally is shorter, true. Yes, it is generally shorter, but then again, sometimes it's not exactly the syntax, more about the readability aspect of it.
There is a lot of overlap too. I mean, there are a lot of things where both C# and F# work just fine.
Yeah.
So you just pick.
It really is your problem in your hand. F# generally on the average will have a 2 to 3 times less code than the C#. Part of the reason also is because you don't have those curly brackets.
Another answer to that question about functional versus non-functional is sometimes when you're writing these functions, you produce a lot of garbage that you need to clean up after, and sometimes the garbage collector has to come back and clean up before it can continue, and you might actually care about it being fast, so you might have to write a couple of things more mutably so as not to use quite so much memory. So there are occasions where you will do that. You'll just sort of try to minimize the scope of the mutation as much as possible and try not to let it the mutation leak outside of the function. So.
You see, your computer is essentially a state-based machine, Van Neumann model of computer, right? So F# is actually translating that to C#. So when you want to use a finer control, where I want to predict what my memory usage is, how the computation was, C# will have, or C++ particularly, is a low-level language, right? You can predict, you can have a lot of predictability on your code, on how actually it will run on the machine. F#, the compiler is doing things automatically, so you don't have that visibility.
You can have the control, it's just not by default.
Yeah, I mean,
Like,
sure.
we have in our code base quite a bit of mutability, but it's all within a certain scope inside of a function. So from the outside, the function still looks like it's pure. We do some mutation on an array or something in order to make the computation faster. But, it's still just a little component that you can treat as a pure function. And so it doesn't really, it's totally fine, and it fits in the framework of FSharp just fine.
You cannot write a better quicksort function in F#. You need to have a mutable state.
But there's nothing that stops you from doing that. It's just a function. You're taking an array and returning an array. Who cares what it's doing on the inside?
But the whole notion of a quicksort is just sorting gigantic array.
No, but you don't have a program that's just quicksort. Quicksort is like one little part of your program.
Yeah, of course.
So it's going to be a library call I mean, the nice thing about having pure functions is when you knit them all together, it's very easy to understand what your program is going to do, and it's easy to change it. So it's okay if some of those little parts, like if you look in the FSharp core library, it's not like all immutable in there. They do whatever's fast.
Right, if they write array.map as create an array, and then take each thing of the original array and build the thing. Just, you don't see that. You don't see that when you're using it. That's hidden away from you. But that's indeed how array.map is written.
Or like list.sum, we saw that it could use a mutable or it could be folding internally. You don't know. It doesn't matter as long as the performance is right for your application. I think that was recently changed in the implementation just to make it a little faster for the people who care. But the result is the same, and the ability to reason about it in the sense of purity is the same, even though internally there is that effect. It's still a total function.
Externally, it's not dependent on anything external, so you don't care what the internal implementation is. Okay, so I have my email for those who want to have a copy of the slides. Please feel free to email me. I can email it back, and anything that I can't do in public, I always can do it in a private conversation. If you want some of those books or reference material, I'll be happy to email you the PDFs for it.
All right, thank you, Nikhil.